Hello everyone, it's Mr. Spinelli, and today we're going to talk about circumference and area of circles. Now I've got a little analogy at the top. Perimeter is to polygons as circumference is to circles. What that means is that circumference is simply the length around the outside of the circle, which is technically the perimeter of the circle. Now in order to find the circumference, all I need to do is multiply 2 times pi times r, where r is my radius. Now if I keep in mind that my radius is half the length of my diameter, then circumference is also given by pi d, where d is the diameter. So you can use either one of these equations, 2 pi r or pi d, but you need to remember that the diameter is twice as big as the radius, which means the radius is half the length of the diameter. So there's two ways to think about it, but that is how you find the circumference of a circle. Now in order to find the area of a circle, that is all the space in between, area is simply pi r squared, where again r is still your radius and d is your diameter. If you choose to use the diameter, when you square it, you end up dividing by 4 in order to find the area. Most people are going to use this first equation, pi r squared. So if you've got the diameter, divide it by 2 and plug it into that equation I've underlined. Otherwise, you can use the one on the right. So let's see this in a few examples. So we're going to find the area and the circumference of these circles. In some of these we've got a picture, in other ones we've just got the words. So in the first one I've got that the radius is 5 centimeters. So I'm going to denote that that's r. So in order to find the area, I need to do pi r squared. So I need to do pi times 5 centimeters squared. Now an exact answer would just be 25 pi centimeters squared. So all I'm doing is writing the pi next to the number I get, because that's the exact answer. I could go ahead and type 25 times pi in my calculator and get a decimal expression, but this is the exact answer. So all I needed to do was square that 5 and write the pi next to it. Now for circumference, I need to do 2 pi r. So I'm going to have 2 pi times that 5 centimeters. So I end up with 10 pi centimeters. Notice centimeters, my units for circumference is just the units. My units for area is the units squared. All right, now the next one, we've got that the diameter is 20. So that's the d. So in order to find the area, I'm going to go ahead and divide that by 2. So I'm going to do pi times 10 squared, and I get 100 pi feet squared. Now if I had done 20 squared, I would have got 400, and I'd have to divide that result by 4 to get the 100 pi. Now in order to find the circumference, I'm just going to use pi times d. This is where life is easy with the diameter. So all I got to do is write the pi symbol next to the 20 and include my units. If I had divided it by 2, I would have ended up multiplying it by 2 to get the circumference. Now the next two are very much the same. The only difference is I've got a picture. So on the first one, I'm going to square the 10 because that's my radius, and I get 100. So I'm going to get 100 pi centimeters squared. And then in order to find the circumference, I'm going to do 2 times the 10, which gives me 20, and I also have to multiply it by pi. And on the last one, I've got a diameter of 38, so then my area is going to be, I'm going to take half of that, which means my radius is 19. I'm going to square that, and I get 361. So I've got 361 pi. Units are centimeters squared. And for circumference, 38 pi centimeters. So keep in mind the formulas. You've got area equals pi r squared, which is the same as pi diameter squared over 4. And for circumference, you've got 2 pi r if you use the radius, or pi d if you use the diameter. So you've always got two things you can work with. So now let's take a quick look at some things backwards. And you may not see these as often, but now I want to find the radius and the diameter given the area. So what I'm going to do is I'm going to write that this equals pi r squared. So 16 pi equals pi r squared. Well, if I divide both sides by pi, then the pi's reduced to 1, so then I just got 16 equals r squared. Well, in order to solve for something when it's being squared, I have to square root both sides. So I take the square root of r squared and I get r, and I take the square root of 16 and I get technically plus or minus 4, but I've never seen a circle with negative radius. So my radius is simply 4 inches. And to get my diameter, I just double that. Next one, I'm going to need to pick up a calculator because I've got a decimal expression. So if I divide the 53.4 by pi, so I'm again going to divide both sides by pi, I'm going to get 16.9977 and some change r squared. Now I have to square root that, and I get something just over 4. I get about 4.12 feet. And then to find the diameter, I simply double it. Now on the last question, number 7 here, it's asking me to find the circumference. Now the only thing that changes is, once I find my radius, I'm going to multiply it by 2 pi. So I'm going to set the area equal to the formula for area, which is pi r squared. So whenever I'm given the area, I set it equal to pi r squared. And then I do some algebra. So now I divide both sides by pi because I want to get r by itself. So then I end up with 8 equals r squared. I'm going to square root both sides. So I get r equals the square root of 8, which is simply about 2.828. So now that I've got my radius, I want to find my circumference. Well, circumference is 2 pi times r, and in this case my r is the square root of 8, or it's 2.828 approximately. And when I carry that calculation out, I get 17.77 centimeters, or if you're looking for an exact answer, you get 4 root 2 times pi centimeters. Those are two equivalent expressions. So again, the key with area is that you always write out the formula. And you're going to want to replace the a with the number that you were given. In this case, it was 16 pi. On number 6, it was the 53.4. And on number 7, it was 8 pi. You replace the a with the value you're given, divide both sides by pi, and then square root to find the r, the radius. Once you've got the radius, there's so much you can do. So now let's briefly talk about what we have when we just have a sector of a circle. Now a sector of a circle is simply like a piece of the pie. So if you cut out a few pieces of the pie, what's the area of what you cut out? And it's really quite simple. All you need to do is figure out what portion of the pie you have. Do you have half of it, a fourth of it, a fifth of it, some crazy decimal amount of it? What percentage of the pie do you have? And in order to do that, you need to find the measure of this angle for the arc, take that measure of that angle, divide it by 360 because a full revolution to make a circle is 360 degrees. So once you divide that by 360, this portion of the equation tells me what percentage of the pie I have. Really the percentage of the circle. And then I simply multiply that by pi r squared, which is the area of the full circle. So I'm computing some percentage of the area of the circle. So let's just take a quick look at some of these examples. So recall, my equation is the measure of the arc divided by 360 degrees and then times pi r squared. So this first one, I've got a 90-degree measure of my central angle, which is also the measure of the arc. That's a key connection. Central angles are equal, the measure of a central angle is equal to the measure of the arc. So I'm going to take 90 degrees divided by 360 degrees, and then I'm going to multiply that by pi r squared. In this case, my r is 16. Now, one way to look at this is 90 divided by 360 is just 1/4. So I have a fourth of the pi, a fourth of the circle. So when I square 16, I get 256, and I multiply that by pi, and I end up dividing this result by 4. So when I divide that result by 4, I get 64 pi meters squared. So on the next one, my angle is now 45 degrees. So I'm going to take 45 degrees, divide it by 360 degrees, multiply that by pi r squared. In this case, my radius is 15. So if I do 45 divided by 360, that's 1/8. So this is 1/8 of the pi. So I get 1/8. If I square 15, I get 225. And again, all this is just multiplied by pi. So my answer is simply 225 over 8 times pi, and then my units are miles squared. Now you could go ahead and type this one into your calculator, and you'd get 28.125 pi miles squared. And if you wanted, you could even multiply the 28.125 by pi. But I'll leave that exercise to you. Now on this last one, I don't have the measure of my arc. Okay? I need to find the measure of that arc. So in order to do that, I need to remember that a full circle is 360. So if I take 360 degrees minus the 135 degrees, I find that the measure of this arc, or that central angle, since they're the same, is 225. So I've still got to use my properties of what I know about a full circle being 360. A diameter or semicircle, whichever way you want to think of it, forms a linear pair. So you might be given a portion, like let's say on this one, I had given you that this was 135 degrees. You would have needed to do 180 minus 135 to get the 45. So just keep in mind you've got to continue to use all the skills you've learned. So now I apply my formula. I know the measure of my arc is 225 degrees. I divide that by 360. I multiply that by pi times the radius squared. So what I'll notice is this is equal to 5/8 of the circle. So I'm going to do 5/8 of the area of the circle. Well, the area of the circle is 121 pi. Then if I rewrite this, this is simply 605 pi over 8 miles squared, which you could also write as 75.625 pi miles squared. All right. Key thing is that you take the measure of your arc and divide it by 360. That determines what percentage of the circle you have, and multiply that by the area of the entire circle. Now something else you might see is the length of an arc of a circle. So now let's say I've got the measure of this arc. Okay, same thing as before with area, but I want to find the length of this arc. Well, keep in mind, I know the entire length of the outside is simply 2 pi r. That's the circumference or perimeter of a circle. So I take the circumference of the whole circle and I multiply it by what percentage of the pi or the circle that I have. It's the same process. So now in these ones, you'll notice that I used all the same circles just for the sake of simplicity. So remember this one, I had 1/4 of the circle, this one was 1/8, and this one turned out to be 5/8. And again, I got that by taking these angles, 90, 45, and this ended up being 225. Divided those by 360 to get these fractions that I've written in green. So now to find the length of these, the length of that arc is going to be equal to 1/4 of the circumference. The circumference is 2 pi times 16. So if I do 1/4 times 2 times 16 and then times pi, I get 8 pi meters. On this one, I do 1/8 times 2 pi. That turned out a little weird. Times its radius of 15, and I end up with 15 over 4 pi miles. And on this one, I've got 5/8 times 2 pi times the radius of 11, and I end up with 55 pi over 4 miles. Now, one thing you may be wondering is, why did I write the pi here and why did I write the pi in the numerator versus next to it? Doesn't matter. It's still the same. It implies multiplication. Thank you very much for watching and have a wonderful day.